Section 4.5 is where we take what we've been learning about the equations of lines in all the different forms and apply those ideas to parallel and perpendicular lines. So you'll see in this first part, we're going to look at parallel lines on the left side and perpendicular lines on the right side. So we'll start with part A, where it says these lines are, and we're going to look at this, and it appears that these two lines are parallel, meaning they will never intersect. So let's fill in that first blank with parallel. And again, that means that they will never run into each other. So next we are asked to find the slope of line A and of line B. Now remember, when you're asked to find the slope of a line, given the graph, you pick out 2 points, which are already done for us, and we're going to count rise over run. So starting with line A, which is the blue line, let's count up 2 units and over 1. So 2 divided by 1 is 2. So the slope of line A is 2. Let's move on to line B, which is the red line. I'm counting up 1, 2 units and over 1. So again, 2 divided by 1 is 2. So again, these lines were parallel, and we see that the slopes of parallel lines are the same. So therefore, parallel lines have, and this is where we're going to fill in with the same slope. Parallel lines have the same slope. And that's definitely something I would write down in my notes. Parallel lines have the same slope. So anytime you are told that you have 2 lines that are parallel, you can automatically assume that they have the same slope. Next, let's do part B. These lines appear to be perpendicular, meaning that when they intersect each other, they form right angles in all 4 angles that are formed. So again, these lines appear to be perpendicular. And just like before, we're going to now find the slope of line A and the slope of line B. The points are already picked out for us, so it's just going to be a matter of counting rise over run. So let's start with line A, which is this line right here. I'm going to start with my leftmost point, and I'm going to count down 1, 2, 3, 4, and over 1, 2, 3. So I went down 4 and to the right 3. So I have a slope of -4/3. For part B, I'm going to count up 1, 2, 3, and over 1, 2, 3, 4. So I have a slope of 3 over 4. Notice, in order for them to be perpendicular, one of them had a negative slope and one of them has a positive slope. So we have a -4/3 and a positive 3 over 4. Also notice I had -4 over 3, and now I have positive 3 over 4. So there's a relationship here. If you have perpendicular lines, they are opposite, meaning one's negative and one's positive, reciprocals of each other, meaning all you got to do is flip over the one number to get the second numbers. So again, perpendicular lines have opposite reciprocal slopes. And again, this is something that I would definitely write down in my notes. Parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. So let me give you an example. If you were told that the slope of one line, so m equals 3, the slope of the line that's perpendicular, so you'd say the slope of the line that's perpendicular, that symbol right here means perpendicular. So if my original slope is 3, the slope of the perpendicular line would be negative, because that's the opposite part, and the reciprocal of 3, which is technically 3 over 1, would be 1 over 3. So these are opposite reciprocals. One of them was positive, one of them was negative, and I flipped over this number to get 1 over 3. Let's look at another example. Let's say that our original slope is -4. The slope that's perpendicular, this one is negative, so my opposite reciprocal would be positive, and the reciprocal of 4, which is technically over 1, is positive 1 over 4. What if I had an original slope of positive 1/3? So the opposite reciprocal, the original is positive, so our perpendicular slope would be negative, and the reciprocal of 1 over 3 is just 3 over 1, or just 3. So again, opposite reciprocals. One of them is positive, one of them is negative, and then you just do the reciprocal, meaning I flip the number over to find the other slope of the perpendicular line. So let's do an example. So this is actually example number 2. Write an equation of a line that passes through the point -3, -5, and is parallel to the line y equals 3x minus 1. So I see a few keywords in here. I see it's through this point, and that point is not the b value since it's not 0 something, and I see that it is parallel to this line. So my first thought is I know that parallel lines have the same slope. So if I know what the slope of this line is, I know what the slope of the equation I'm supposed to write is. So since this is in slope-intercept form, since y is by itself, the slope of this line is 3. That means the slope of the equation that I'm supposed to write has the same slope since it is parallel, so the slope of the equation I'm supposed to write is 3. And again, it has to pass through this point, -3, -5. Now the question always comes up, what do I do with this -1? I only use this equation right here, I only use this equation to find the slope. I only needed the slope from this equation because I was told that the line I'm supposed to write is parallel to this line. So the answer to the question is, what do I do with this -1? Is nothing. I only use this equation for the slope and I throw the rest of it away. I only use the 3. So again, don't think you need to do anything with that -1. I now have a point and a slope, and it just says write an equation line that passes through this point parallel to this line. So now I have a point and a slope, so I can write my equation in point slope form. So I'd have y plus 5 equals 3 times x plus 3. Since the equation I was given here was the y was by itself, it was in slope-intercept form, I'm just going to finish this by distributing and getting y by itself. Not that it necessarily told me this in the instructions, but this is what I'm going to do just to have some consistency in my answer. So I distributed first, I'll subtract the 5. So again, my goal is to get y by itself, so I have y equals 3x plus 4. So there would be my final answer. I could have stopped here though, however, because I was not told what form to write the equation in. On a test or a quiz, you always will have the choice whether to write it in point slope or slope-intercept, unless it's otherwise told to you to do it in a certain form. Here's another example, just like the last one. Write an equation of a line that passes through 4, -5 and is parallel to the line y equals 2x plus 3. So again, I see that word parallel. I know that lines that are parallel have the same slope. So if I know what the slope of this line is, I know what the slope of the equation I'm supposed to write. So the slope of this line is 2, since that is the number in front of x. Since the slope of this line is 2, the slope of the equation that I'm supposed to write is 2. I am not going to do anything with this plus 3. I am only using this equation for the slope, and then I throw the rest of it away. So now I have a slope of 2 through the point 4, -5. So again, I have a point and a slope, so I'll write my equation in point slope form. Y plus 5 equals 2 times x minus 4. And again, just to keep some consistency in this problem, since this equation was given to me in slope-intercept form, meaning y was by itself, I'll get this equation where the y is by itself. So I distribute first and then subtract 5. So my final equation, y equals 2x minus 13. And again, I was not told what form to write this equation in, so I could have stopped here, since that's technically an equation of the line through that point parallel to the given equation. But again, I just like to get y by itself, especially when the equation I was originally given was the y was by itself. Our last example says determine which lines, if any, are parallel or perpendicular. It says justify your answers using slopes. So I see parallel and perpendicular. I know that parallel lines have the same slope, and I know that perpendicular lines have opposite reciprocal slopes, and I'm supposed to justify my answer using slopes. So I'm going to first find the slope of each of these equations so I can compare them. If they're the same, they're going to be parallel. If they're opposite reciprocals of each other, they'll be perpendicular. So when I look at line A, I have y equals 5x minus 3. The y is by itself, so since the y is by itself, I know that the number in front of x is the slope. So this slope is 5. When I look at line B, it says x plus 5y equals 2. So the y is not by itself in this equation. This is actually in standard form. In order to identify what the slope is, I have to have y by itself. So that's what I'll do. The first step would be to subtract x. So I'd have 5y equals 2 minus x. And I would divide both sides by 5. So I'd end up with y equals 2 divided by 5 is 2/5. And remember, there's technically a 1 in front of there, so -1 divided by 5 would be -1/5 x. So the slope of this equation would be this -1/5. So I'll write that kind of off to the side here so I can see it better. So again, line B has a slope of -1/5, and I did that by finding the y by itself. Line C is -10y minus 2x equals 0. So again, y is not by itself, so my first step would be to get y by itself, add 2x to both sides. 0 plus 2x is 2x. And then I'm going to divide by -10. Putting that into lowest terms, positive divided by negative is a negative, and 2/10 is 1/5. So now that y is by itself, I know that the slope of this equation, line C, is -1/5. So looking at these three slopes, slope is 5, slope is -1/5, and slope is -1/5. The lines that are parallel, the first one I have here says lines blank are parallel because lines B and C would be parallel because they have the same slope. Lines blank are perpendicular because, so again, perpendicular lines have opposite reciprocal slopes. So if you look at this, I have a positive slope and a negative slope. So there's the opposite, and then the reciprocal of 5, which is 5/1, is 1/5. So line A would be perpendicular to B, and since B and C have the same slope, that means that line A is also perpendicular to line C. So lines A and B and A and C, they are perpendicular because they have opposite reciprocal slopes. And that's it for this section. We will do a handful of problems in class, but make sure in the meantime that you have all of these examples written down to refer to when you go to do your own homework by yourself. As always, write down anything you didn't understand so we can cover that in class as we go over the example problems, and we'll see you then.